Welcome to another video. China's startup chip 500 times faster than Nvidia A10. That is China's self-developed optoelectronic hybrid technology. The optoelectronic hybrid chip technology from China has appeared in the latest top journal Nature. Before I go further, we need your support to continue bringing you the latest news, analysis and live information. Please give us your support, smash the like button, comment, share and subscribe to all. In fact, all these had already been predicted in a book written 2 years ago. In 2023 I wrote a book called China 2023, the epic of global dominance about China achieving global dominance in 2023. My book is an unbiased analysis of how it happened, the history of China's reemergence in the short span of the past 40 years. My book also predicted China's rapid high-tech revolution, Russia winning the Ukraine war, the decoupling of the world into two camps of the global south and the west, the prosperity of the global south countries and the decline of the US. The goal of China is to bring prosperity and harmony to the world. All my predictions have become reality. This power shift has deep and far-reaching impacts on the future of humanity. Please click the links below to view my book and purchase. We need your support to continue. Back to the subject of today's episode. This achievement mainly focuses on the self-developed photonic computing processor, PACE Photonic Arithmetic Computing Engine. Simply put, PACE is an architecture based on optoelectronic hybrid, which can achieve ultra-low latency and high-energy efficiency computing by performing matrix vector multiplication through light. According to the data disclosed in the paper, PACE has a computing delay of as low as 3 nanoseconds when solving combinatorial optimization problems such as Ising problem and maximum cut, minimum cut problem, which is 2 orders of magnitude faster than traditional GPUs. The core of this breakthrough lies in the highly integrated design of PACE. This system integrates more than 16,000 photonic components and seamlessly integrates photonic integrated circuits PICs with electronic integrated circuits ICs through innovative 2.5D hybrid advanced packaging technology. This design not only solves the technical difficulties in large-scale optoelectronic system integration, but also lays the foundation for commercialization. And this chip technology comes from the domestic startup Shiziu technology. It is understood that this is the second time that Dr. Shen Yichen, the founder of Shiziu technology, has appeared on this top journal after publishing a cover paper in Nature 8 years ago. So how did PACE achieve such speed? First, public disclosure, high integration of 16,000 photonic components. With the rapid development of artificial intelligence, computing needs have exploded, and traditional electronic computing faces bottlenecks in power consumption and speed. Photonic computing has become a highly potential alternative with the unique properties of light, such as simultaneous multiplication and accumulation, low energy consumption for data transmission, and avoidance of resistance loss and heat problems, and has attracted widespread attention from the world. However, photonic computing faces many challenges in its development. On the one hand, the manufacturing of integrated photonics is relatively immature and lacks advanced packaging solutions, which leads to difficulties in performance improvement, standard design and verification, and packaging of large-scale integrated photonic systems. On the other hand, photonic computing has shortcomings in optical storage, computational accuracy especially in large-scale complex circuits, and adaptation models and algorithms, which limits its commercialization process. To this end, PACE proposed by Shiziu technology adopts a hybrid architecture first public disclosure to integrate photonic integrated circuits PIC and electronic integrated circuits IC in a system-level package SIP. PACE system deployment. PIC is responsible for performing optical matrix vector multiplication OMAC operations, while EIC handles control, iterative logic, data input and output, storage, and clock control functions. This architectural design fully utilizes the advantages of photonic computing in speed and low latency, as well as the strengths of electronic computing in logic processing and storage. In PIC, the team designed 160 for optical data modules and 60 for weight modules to perform OMAC operations. The optical signal is coupled into the circuit from the external laser array through a high-performance grating coupler, modulated by the vector modulator array and the weight modulator module, and finally converted and merged in the photodetector array. The EIC is designed based on 28nm commercial CMOS technology, while the PIC is built based on 65nm silicon photonics technology. A single chip integrates more than 16,000 photonic components, achieving high integration. This hybrid architecture fully utilizes the parallel advantages of optical computing. Optical signals naturally complete multiplication and addition operations OMAC when transmitted in waveguides, while electronic circuits handle logic control and data storage. Experimental data show that the delay of 60 for 64 matrix operations is only 3 nanoseconds, which is 500 times faster than traditional GPUs. In addition, the research team creatively applied optical matrix operations to combinatorial optimization problems. By designing a noise-driven recursive algorithm, the PACE system can efficiently solve the Ising model. When solving the 63-node max-cut problem, the system can achieve a convergence rate of 90.7% after an average of 537 iterations to 0.7 microseconds, which is 295 times faster than the Nvidia A10 GPU. Even more striking is the image search demonstration, in which the system can converge from a random initial state to a preset CAD image target. Nature reviewers highly praised the efforts made by the Shiziu technology team in the engineering of photonic computing. In the field of photonic computing, optimistic inferences about the performance of large-scale systems are usually made through small-scale demonstrations, but the data in this article are all from the measured performance of the entire PACE computing system. The authors have engineered a super large-scale photon matrix computing system, which can be called a feat. In the field of photonic computing, optimistic inferences about the performance of large-scale systems are usually made through small-scale demonstrations, but the data in this article are all from the measured performance of the entire PACE computing system. The authors have engineered a super large-scale photon matrix computing system, which can be called a feat. Just recently on March 25th, Shiziu Technology officially launched a new generation of optoelectronic hybrid computing cards, Shiziu Tianshu. Shiziu Tianshu deeply integrates the advantages of optical chips and electrical chips, adopts advanced 3D packaging technology, and is a highly programmable optoelectronic hybrid computing card. Compared with previous generation products, it has achieved significant improvements in optoelectronic integration, photon matrix scale, computing accuracy and programmability. It not only supports scientific computing such as Ising algorithm, but also enhances the adaptability to commercial algorithms such as ResNet 50, further broadening the application scenarios. Shiziu Tianshu adopts a non-coherent architecture design with excellent anti-interference ability and high computing accuracy. Its core processor consists of an optical processing unit OPU and an electrical application-specific integrated circuit ASIC, which work together through 3D advanced packaging technology, with a main frequency rate of 1 GHz and an output accuracy of 8-bit. The area of the optical chip has been increased to 600 square millimeters, the number of devices has exceeded 40,000, and the integration has been greatly improved. In addition, it supports a maximum matrix size of 128 by 128, and its computing power and flexibility have been significantly enhanced. Users can freely configure the calculation matrix coefficients through the API to achieve more efficient optimization and adaptation. In terms of software, the product is equipped with the Shiziu optoelectronic hybrid computing software stack, which supports mainstream frameworks such as PyTorch and ONNX. Users can flexibly build efficient application models through the Shiziu compiler. Not only that, the platform also supports user-defined operators, further expanding the flexibility of algorithm development. In this regard, Dr. Shen Yichen said, Shiziu Tianshu has realized the application of optoelectronic hybrid computing in complex commercial models for the first time, which is an important breakthrough in the productization and commercialization of Shiziu Technology's optoelectronic hybrid computing technology. We firmly believe that optoelectronic hybrid will bring computing power innovation to artificial intelligence, large language models, intelligent manufacturing, and other fields. Optical plus electrical will be the answer to the future. Shiziu Tianshu has realized the application of optoelectronic hybrid computing in complex commercial models for the first time, which is an important breakthrough in the productization and commercialization of Shiziu Technology's optoelectronic hybrid computing technology. We firmly believe that optoelectronic hybrid will bring computing power innovation to artificial intelligence, large language models, smart manufacturing, and other fields. Optical plus electrical will be the answer in the future. Thank you for watching. We need your support to continue bringing you the latest news, analysis, and live information. Please give us your support, smash the like button, comment, share and subscribe to all. Click on the links below to view and purchase my book. Thank you for your support.